Welcome my dear student. So in this lecture series, I am going to solve some of the interesting and challenging numerical problems from the physics book Pathfinder for Physics Olympiad and Advanced JEE. So let us start with the session. So in this situation, what is happening that there is a block which is resting on the floor. Let us say this is the block which is resting on the floor is connected with a very long spring. So I connect a very long spring and I pull one end of the spring with a force F. Here I am applying a force F. Okay. So it has been given that the block, I am applying a force of F, and because of this force, so force is basically acting on the block so that the block will start to move when it will reach a certain value, that is the limiting coefficient of friction. Limiting coefficient of friction. Now here, what is the limiting friction in this situation? That is equals to mu s into mg. There is the limiting friction. That should be equals to F. That should be equals to F, and that is equals to what? Ax naught. So what is x naught? X naught is the extension of the spring before the block actually starts to move. Now let us say this is the x naught number. So corresponding to this, what I can write that x naught, that should be equals to mu s mg by k. Okay. So now after that, if I further increase the value of F, then the block will start to move forward. So before this much elongation, the block is not moving. So after I go for more elongation, then that means I am going for the more value of force. So now the block will start to move. Now the block will start to move. Let us say in the second situation, it is also given that the spring has been elongated from, let us say, another y distance s. So s is the distance traveled by the block. It is given by 6 centimeter. S is the distance traveled by the block, that is 6 centimeters. So in that process, what is happening that the spring is going to compressed by another distance, that is x naught plus s. So there this distance is, there is initially the spring is x naught distance. Now at the final situation, initial is half k into x naught square. That is the initial energy, spring potential energy. That is Uy. Similarly, U final is how much? U final is the final spring potential, that is equals to half k into x naught minus s whole square. Okay, because the block is moved forward by distance x. So that is the net work done. And that basically used to overcome the work done by the friction. So if I apply the work energy conservation theorem, so work done by friction, that should be equals to U final plus K final minus U initial plus K initial. So what is U final? U final is basically equals to half K into x naught minus x whole square. So half K into x naught minus s whole square, or U initial is half K into x naught square. Okay. So what is the work done by the friction? So in the entire process, the block is moved by a distance of s, and during that process, only the kinetic coefficient of friction will act. So this work done by friction is the kinetic friction. So that is equals to how much? That is equals to mu k mg is the force multiplied by s with a negative sign. That is the work done by the friction. So if I rearrange this, so half k into x naught square plus s square minus 2 into x naught into s minus x naught square. That means on the right hand side, I got half k into s square minus 2 x naught into s, this number. And that is balanced by work done by friction. So if I arrange the sign, arranging the sign, what I can say that work done by friction, that is equals to mu k mg into s whole into 2. That should be equals to k into 2 x naught into s minus x square. So from that, what you can write the value of x naught. So if I put the value of x naught in x naught, the value of mu s is there. So that is equals to k times 2 times of x naught, means mu s mg s by k minus s square. Okay. So that gives the value of mu s. So from this equation, if I solve the value for mu s, so ultimately what I'm getting that mu s should be equals to mu k plus s into k divided by 2 times of mg. So this is the answer that I'm getting. That is the coefficient of static friction. So in this situation, you are asked to calculate the coefficient of static friction between the block and the floor. So mu s is this much. Okay. So if you put all the values, then you can get the answer. And once you got the answer, please mention in my comment box so that I can check whether you are getting the correct or not. Okay. So hope you understand this. Thanks for watching the video. And if you like it, please subscribe my channel.